In this section, I'm going to talk about how to make grayscale images and code to play around with that idea. So the first question is, how do you make a gray color? So to play around with that, I'm going to go over here to the RGB Explorer. And it turns out in the RGB scheme, the way to make a gray color, one that lacks any hue, is for all three numbers, red, green, and blue, to be the same. So I can demonstrate that here. I'm going to put red and green up to be the, I'll put them all at 190. Oops. So you can see that's kind of a fairly bright yellow, and blue is down here. So watch what happens as I drag blue up towards being the same as red and green. You can see the color is kind of drained out of it. And just as blue gets to be exactly the same, and you can actually use the arrow keys on these controls. There, now that all three are exactly 190, what we're left with is just gray. So we can, I'll do another example. So if I put, I'll put green and blue down here sort of at the middle, so they're both at 99. It's kind of a, I don't know what that is. Well, it's a dark turquoise if I put red at 0. So then I'll bring red up to be closer and closer, and then once it is the same as the other two, then again I'm left with gray. In this case, it's kind of a dark gray. So the pattern is, if red, green, and blue values are all equal, they're all the same, then that's going to be some shade of gray. And actually, our original cases of pure black and pure white, I'll make black here, they follow that too, right? And black, it's 0, 0, 0. They're all the same. So that's actually one endpoint of the grayscale spectrum. All right, so I'll go back here, and we'll say that so we can make these if we put all the RGB values to be equal, that'll make a shade of gray, and we can make dark gray and light gray and black or white or whatever. We'll say that those shades of gray, another way of saying it is that they lack hue. So they're not towards red or green or anything like that. There's just this colorless brightness. So in this table, I just have some examples. So for example, if I had something that was 50, 50, 50, that's sort of a dark gray, or 120, 120, 120, that's medium gray, or 200, 200, 200, that'd be a light gray. And as I said before, the pure black and pure white cases that we talked about before, those fit this pattern as well. All right, so how can I do something useful with this? So I'm going to look at this unusual image here, the Liberty-Red JPEG, and I'll just run this code. Right now there's no code in here, so we'll just see it natural. So the Liberty Red image here, it's a picture of the Statue of Liberty, but all of the data is in the red values of the pixels. So the red values are 37 or 200 or whatever. They're varying to show this image. The green and the blue values are just 0 everywhere. There's nothing there. So I mean, whatever. It looks bad, or it certainly looks wrong. So I want to think about, well, how could I fix that? I'd like to fix this to look like a grayscale picture of Statue of Liberty, not this red thing. So the way to do this, I'm going to use this, the fact that if the green, blue, and red are all the same, that's going to be a shade of gray. Now in this case, the data is in, for each pixel is in the red value. So if I say pixel.setGreen, and what I'm going to do is I'm going to make the green value, I'm going to change it to be the same as the red value. So I'll do that by saying pixel.getRed here. So what this does is, with the pixel.getRed, that sort of picks the number out of, this is for each pixel. It picks up the red value, so 27 or 100 or whatever it is, and then sets it in to be the green value. Now this is a little unusual. Usually we call set green, we've mixed it with get green, and set blue we've mixed with get blue. But this is a valid combination as well. And it happens in this case, it does what I want. So then I'll do it again for blue. Oops. So I'll say pixel.getRed, and then I'll set that into blue. I'll neaten this up. All right, let's try that. Ah, there we go. So this is just an application of this feature of the RGB space, that when the numbers are equal, it's grayscale. And so I sort of retrieved the value out of the red, and I set it over to blue and green, so now it sort of fixes the image. So it looks, it's black and white, but at least it looks okay. So a related question, maybe a more practical question is, well, if I've got a color image, like here's our old flowers image, how could I convert it to grayscale. And the way I'm going to think about that is, if we're looking at here at these flowers, it's like, well, I want to drain the hue out of it. I just want to think of each one of these pixels as being dark or light, just having some amount of brightness. And obviously there's many examples in this image. So the problem is going to be looking at a pixel, how dark or light is it? That's what I want to reduce this down to. So suppose I picked 3 pixels out of that image and I put them in this table. And now I want to think about which one of these pixels is darkest and lightest. So here's the first pixel, and here's the second pixel, and here's the third pixel. And here I'll zoom in on this a little bit. So I'm just trying to judge light versus dark. Who's the light? What's the lightest? What's the darkest here? So suppose if I was just looking at the red values, I'd see that this first pixel has a red of 200. And then that's just much brighter than the others, right? I mean, high numbers are bright. 255 is the max, and 0 is black. So it looks like, oh yeah, this first pixel, 200, that's clearly the brightest. But then if I look over in at the green values, then it's like, oh gosh, but this third pixel actually has a really high value for green, even though it's kind of low for red. So I'm not quite sure how that balances against the other pixels. So it's hard because essentially what we see is that you can't just look at one of red, green, blue to judge how bright the thing is. You sort of want to count them all. So our solution in this case, which I have in the fourth column here, is to compute the average for each pixel. So each pixel has a red, green, and blue value. What I'm going to do is just compute the average of those 3 numbers. And the way to do that is you just add them up. So I'm just going to compute red plus green plus blue for each pixel, and then just divide by 3. So that'll give us the average value of the red, green, and blue. And that average value is going to work as a pretty nice summary of just how bright the pixel is, right? So if the average is 0 or 10 or 20, some low number, we don't know what hue it is exactly, but we know it's dark. And at the other end, if the average is 220 or 240, again, we don't know what the hue is, but we know it's bright. So the average is going to work as a kind of a summary of the pixel, where it drops out the hue and just gives us one number, 0 to 255, that just captures the brightness. Now, I should say, there's other ways of doing this, but just computing the average is simple and it's fine. It's going to work fine for our purposes. So in this case, I had these 3 pixels, and so here on the right-hand side, I just computed the average. And what we see is, really, the third one is by far the brightest. If you look at all 3 of red, green, and blue. And then the middle one is the darkest, and the first one is kind of medium. All right. So I can use this idea that I've got the average, and it sort of makes this nice one-number summary. I can use this to convert something to gray. So let's try this. So here I've got I'll just run this. So inside the loop, there's no code here. So if I just run it now, we just see the image unchanged. So what I'd like to do is add the code here to change this to grayscale. So I should say what my strategies can be. So what I'm going to do is in the loop for each pixel, I'm going to compute this average number. So just get one number. So it might be 27 or 100 or whatever for each pixel. And then I'm going to take that number and set it into the red, green, and blue. So if the average is 27, I'm going to make red, green, and blue all be 27. And if the average is 211, then I'm going to make red, green, and blue all be 211. So that converts each pixel into the grayscale spectrum we saw before. So first off, I have to compute the average here. So I'm just, as I said, you add them up. So I'll say pixel.getRed plus pixel.getGreen plus pixel.getBlue. And then I'm going to put those 3 inside of this outer set of parentheses, just for the order of operations. So I want to do the addition, and then I'll say /3. So I'm going to divide by 3. So this does the addition in the parentheses, and having gotten that sum, it divides by 3. And I'm just going to store that in a variable called AVG. And this line, it's going to turn out to be kind of a stock line for us. There's many little techniques or problems we might want to do in the future where we want to compute the average, and inevitably the line will look kind of like that. All right, so what do I say? So my strategy is I compute the average, and then I set red, green, and blue to all use that. So I'm going to say pixel dot set red, and then here I've stored the average. This is just a variable, so I've stored the number in there, and then inside here, so I can just say AVG. I'll just go to that variable and get the number back out. And likewise, I can say set green AVG and pixel dot set blue AVG. Okay, so let's try that. Very good. So you can see this is it works. So it's gone through all these pixels, red or green or whatever. It's reduced it down to this one average brightness number and then set that back. So we get this nice sort of grayscale. So actually, having tested it out on flowers, I'm going to go back to the poppy image, which I think appears in one of the exercises. So here, if I comment these 3 lines out and just run it right now, we'll just see the poppy image. There it is. So I'll scroll to the right here a little bit. So you can see that's obviously, it's got this sort of orange California poppy look and the faded background here. So now I'll put these lines back and we can try our algorithm on that one. There we go. That works pretty nicely. So you can see, obviously, the orange and the green, it's all been drained out, and each pixel has been reduced to just the brightness. And I like here how the texture on the front of the poppy is still kind of visible. So there you have it, suitable for framing. All right. So a question that often comes up, looking at this code, is that line, average equals, and then this formula for the average. Does that need to be inside the loop? It feels like perhaps it could be just here, up after the image equals lines, and the answer is no. It can't be up there. It does need to be inside the loop, and the reason is what you could think that this line sort of sets up a relationship about average that must be true for all time, like as if it's just true at all times as the program runs. And that is not how computer code works. Computer code is less sophisticated than that. What this line does with the equals is it just evaluates the right-hand side and assigns it into this variable on the left-hand side when this line is run. So if we were to put this up at the top, it would just run once, and it would store some number in AVG, and that would be it. In this case, remember, we're inside of this for loop here. I'll kind of highlight the body. And so this code is running thousands or maybe millions of times, once for each pixel. And those pixels each have different red, green, and blue values, right? So this sum is different thousands of times. And so what we need is to compute this sum anew for each pixel. Each time we see a new pixel, we need to redo this math. And so the way the equal sign works is it's just evaluated when the computer runs across it. And so for that reason, because each one of these pixels is different, we need to put it, very often we'll just put it as the first line inside the for loop, just compute the average. So that's why that needs to be there. All right. So just to kind of summarize, so we've learned this quality that if the red, green, and blue are all equal, that's a shade of gray. And we've got this technique where we could compute the average, and that just gives us this one brightness number basically from 0 to 55. And that's going to be, I'm using it here for grayscale, but actually in the future we're going to use that for some other stuff. It's just a useful thing to know. And finally, I'll say that this line, which I was highlighting before, average equals, add the 3 up and divide by 3, that's going to be kind of a stock line. And so we're going to end up using exactly that line later. And in fact, it should show up in some exercises.